Hello, my name is Bradley, and in this presentation I'll be covering the potential impact to IT security of incorrect configuration of firewall policies and third-party VPNs, and how implementing a DMZ, static IP, and NAT can improve your network security. A firewall is the network security between a network and the internet, and is normally built into a router. However, it can also be shown as a software. What this does is it monitors and manages the network traffic to see whether or not it should pass through based on answers of a set of preset questions. For example, what port is the packet from? Where is it going? What protocol does this have? Is the protocol allowed to be used at this destination? If incorrectly configured, this can cause traffic problems on a network, like letting through malicious software, hackers, and so forth. It can also block important traffic from passing through when needed if misconfigured. Not only can this affect a single end user, it can affect an entire network. A third-party VPN is used to encrypt computer activity on the internet and is short for third-party virtual private network. What happens in this is a VPN client will encrypt a packet from a host and send it to the VPN server through the respective internet service providers. The VPN server then decrypts it and resends it to the web server using its own IP address through the respective internet service providers of those two. Once retrieved, the web server will then send back its response to the VPN server. The VPN server then encrypts this and sends it back to the host where the client decrypts it. In the event of misconfiguration, many issues could arise, including DNS leaks, varying levels of encryption, and finally, no VPN services. In the case of no VPN services being active, the host's original request is then open to be looked at by the internet service provider and traced back to a specific IP address, rendering the entire subscription or sign-up process moot. Demilitarized Zone, or DMZ. To understand a DMZ, we must first look at the reason we need them. When a company owns a web and email servers that are used by the public, they generally have them set up in their own network. When the public uses these servers, what happens is all sorts of users are able to penetrate the network, as using these servers will have already allowed them access to the internal or private network. How do we stop this? The way most businesses stop this is by moving the servers to the other side of a firewall, and for some companies that's as far as they will go, leaving the web servers completely unprotected against the untrusted networks or external users or internet. Although the servers are no longer inside the private network and the access point has been removed, the servers are still vulnerable to attacks and viruses from the internet. The solution? The solution to this is to add another firewall to the other side of the servers. This solves every primary and secondary problem talked about so far. The servers are not inside the private network, the access point has been removed, and the servers are less vulnerable, causing most businesses to be happier in the safety of their internal network and their servers. Static IP. Static IP means a single host is given a permanent IP address. The reason for this is as follows. In network 1, there are two computers that have been configured to have a dynamic IP address, which require a DHCP server. Any user is able to create a fake DHCP server with their PC. These computers with dynamic IPs will now boot, request an IP address, and the fake DHCP server will give them one. It can also set its own IP address as the default gateway for the network that consists of these computers, and the user can also set the DNS server address as their own, meaning they can monitor any and every packet leaving and entering the network via these computers. When using static IP, however, this isn't possible. This is because a static IP will have a default gateway and DNS already configured. This means whilst the fake DHCP server is sat waiting for a request, the static IP computers are happily booting up without having to request an IP, meaning no redirecting network traffic. NAT. NAT is short for Network Address Translation. And what this does is uses a network of private IP addresses and merges them into one public IP address. The reason for this being a good network security is because NAT acts as a basic firewall, allowing data packets in that are requested for and not allowing those that aren't, meaning any malicious software sent to attack a network, for example a DDoS attack, or any malicious software that has infected a host, for example a virus, won't be able to circulate around a network without first being requested, preventing further infection of a network. Thank you for listening.